Okay, so another example here of using a double angle identity to solve a trig equation. So here we're going to solve sine of 2t equals sine of t. And again, we're going to find solutions on the interval 0 to 2 pi. This one will actually be, I think, a little less involved than the first one. Sine of 2t, we can simply write that as 2 sine t times cosine t equals sine t. And again, be careful. You don't want to divide both sides by sine t. You would end up throwing some solutions out the window. So what we're going to do is we're simply going to subtract sine t from both sides, set that equal to 0, and now we can factor the sine of t out. That'll leave us with 2 cosine t minus 1 equals 0. And now all we have to do is simply just take each factor and set it equal to 0. So we'll set sine of t equal to 0. We'll take 2 cosine t minus 1 and set that equal to 0. Well, we can add 1 and divide by 2. So now we're just thinking about solutions. I'm thinking, okay, where does sine of t equal 0 on the interval 0 to 2 pi? Well, that would happen at the angle 0, at the angle pi, and at the angle 2 pi. Cosine of t equals 1/2. Let's see. Cosine of the angle, let's see, I believe pi over 3. Cosine of pi over 3, that gives us 1/2. And down in quadrant 4, we'll also find the angle 5 pi over 3 as our other solution. So in this case, we've got 5 solutions to our original equation. Sine of 2t equals sine of t. We've got 0, pi over 3, pi, 5 pi over 3, and our last solution we found was 2 pi.